This question asks us to do 4 things. It asks us to derive a rate law from the given data, determine which molecules are present in the rate determining step, draw a transition state for that step, and propose a mechanism for the overall reaction. Let's go ahead and do that. Looking at the data, what I notice is that as we look at the concentration of the alkyl halide, as I double the concentration, the rate of the reaction also doubles. That tells me that the molecule, the alkyl halide, is present in the rate law. So the rate for this reaction is going to be equal to some rate constant times the concentration of the alkyl halide. The alkyl halide is present in the rate law for this reaction. As I look at the concentration of OH minus hydroxide, as I double the concentration of OH minus, the rate also doubles. That tells me OH minus is also present in this rate law. And to fill out the table, as we double the concentration of both, the rate quadruples, and so that tells me that both molecules are present in the rate determining step. Both the alkyl halide and the hydroxide molecule are present in the rate determining step for this particular reaction. The transition state then will incorporate both of those molecules into the transition state. So the transition state will have a partially broken alkyl halide bond and a partially formed oxygen carbon bond. The oxygen started out negatively charged, so as the bond forms, that negative charge will start to go away. The oxygen will have a partial negative charge. The bromine started out neutral. As this bond breaks and bromine gets a new lone pair of electrons, it will start to pick up a negative charge, and so it will be partial negative in this transition state. This will be the transition state for this reaction then. Possible mechanism could look like the lone pair of electrons on oxygen acting as a nucleophile, attacking the carbon of the alkyl halide. That builds up too much electron density around that carbon, so we'll break the carbon-bromine bond, depositing those electrons locally onto bromine as a new lone pair. This will form our product. Here's the rate law and a possible transition state for this reaction.